You had better park your curiosity in a cozy seat, as what we've seen in sci-fi movies is about to unfold in reality. And all these wouldn't be possible without magnetically levitating means of transportation. Instead of riding on top of the track, our first hero glides through the air underneath the track. That's why it's also called a sky train. Thanks to the magnetic force, the train has zero physical contact with the track, resulting in a smooth, quiet ride that gives freedom to maneuver. This makes the floating train a competent, fast alternative to the subway at 1/10 the cost and with superior energy efficiency due to the absence of rolling resistance. In general, the basic working principle of a maglev train lies in the simple physics law where magnets' two similar poles repel each other, while two opposite poles attract one another. So there is a line of electromagnets installed on the train and two lines of magnets installed on the guideway that are responsible either for propulsion or levitation. The levitation magnets create a repulsive force with the magnets on the train in the upward direction to make the train levitate. To propel the vehicle forward, an alternating electric current is applied to the propulsion magnets, so they alternate north poles and south poles to attract and repel the magnets on the train with precise timing. This helps pull the train forward from the front and push it forward from behind. Such technology powering Japan's superconducting maglev train is going to be put into the everyday business of carrying commercial passengers by 2027. And despite traveling at 310 miles per hour, it ensures a much smoother ride than conventional steel wheel trains because the only source of friction is air. Without a question, it's a technological marvel. But what if we could eliminate the air resistance by running the train in a vacuum tube that would have theoretically made it possible for this technology to transport people at hypersonic speeds? That is what China's spacecraft manufacturer is working on. The impressive news is that 6 years ago the company was realistic about its prediction to reach a speed of 372 miles per hour in 2023. The main goal at present is to achieve a speed of 620 miles per hour in a vacuum tube system, where the flatness of the track is within a 0.3 mm tolerance to ensure constant levitation throughout its operation. If everything goes according to plan, this will beat the speed of an airplane without any harmful gases and at a tiny fraction of operational costs. If this seems too good to be true, another maglev train has already exceeded the speed of an airplane using a pretty interesting method of propelling the vehicle forward. As a railgun uses electromagnetic force to launch, for example, high-velocity projectiles from a stationary position, this high-mass maglev sled is being shot off and moving speedily along a special track. In practice, such a method has been applied by the US Navy, who used an electromagnetic catapult on the aircraft carrier to accelerate a jet to its takeoff speed within a very short distance. While they encountered some challenges, this method seems to work well with a maglev vehicle, setting the world's highest speed record for electromagnetic propulsion technology. But the exciting news doesn't end here, as China aims to use the very electromagnetic accelerator to launch crewed spacecraft the size of a Boeing 737 into orbit. This will serve the same function that a Super Heavy booster does for a Starship, but to reach such speeds, the launching device must be at least 5 miles long, located in a vacuum tube. This nearly reaches the height of Mount Everest, the highest point on Earth, let alone the huge amounts of power required and remarkable advances in engineering that the new system demands. Anyway, if successful, this will reportedly reduce launch-to-orbit costs to only $60 per kilogram, unlike SpaceX's $3,000 per kilogram. A world-renowned German engineering group, ThyssenKrupp, is working on making what once felt unimaginable a reality that will enable passenger transportation not just within, but between buildings too, to commute more quickly, efficiently and safely. And the key to this is the elevator. Since its invention in 1854, the working principle of an elevator has mainly remained unchanged. But thanks to magnetic technology, the group is changing the course of history by offering the world's first ropeless elevator system that can move not only vertically but also horizontally. Instead of one cabin in one shaft moving up and down, the groundbreaking system allows multiple cabins in one shaft to circulate in a building, thus providing significantly more capacity and much less waiting time for passengers. The system is being constantly tested and evolved at the group's specialized subsidiary, TK Elevators Test Research Center in Rottweil, Germany. ThyssenKrupp is the same company that, in collaboration with Siemens, has built the world's fastest maglev train so far, currently being operated in Shanghai, China. Elon Musk has recently said, "I think we really are on the edge of probably the biggest technology revolution that has ever existed." If you'd also like to be part of these excitements, the renowned Y Combinator-backed Careerist has designed specialized online programs to lift your career above the ordinary and propel it forward. Imagine soon landing a tech job with a six-figure salary. And guess what? You don't even need to code. You can go through the link in the description, or if you are watching on TV, you can scan the QR code so as not to miss out on this special opportunity. As we saw, high-speed maglev trains are the most fundamental breakthrough in railway technology. But what if we have the advantages of a maglev train without getting out of our beloved cars? Researchers have already done real-life experiments where the maglev car's early prototypes fitted with permanent magnets underneath the body reportedly hit 143 miles per hour. But since the heavy magnetic system increases costs and makes cars impractical to drive on regular roads, the scientists have come up with a brilliant idea of embedding only the car's wheels with ring-shaped magnets to achieve levitation. Let's take a look at the animation to see how it works in a simplified language. First of all, unlike magnetic railways, hovering cars will flow on a simple aluminium lane structure, which is much easier and cheaper to integrate into the existing traffic infrastructure. According to the physics law, when magnets start moving, an electric current flows through their adjacent conductors, transforming them into an electromagnet. The faster the magnet moves, the greater the force. In our case, when the car's magnetic wheels start rotating fast, an electric current flows through the aluminium track, transforming it into an electromagnet. And since the direction of the force follows the polarity of the moving magnet, this generates a repelling magnetic force, which leads to levitation and is used to accelerate the car or stop it. That vertical suspension is achieved when the front and rear magnetic wheels rotate at the same speed in different directions. Since the entire body of a maglev car is similar to a traditional car, it can switch freely between a maglev car and a conventional electric car, thus getting rid of the constraints of the track existing in other classical maglev systems. To enhance the maneuverability of a magnetic levitating car, scientists have also started working on a six-wheel variant, where, for example, the mid-side magnetic wheels can rotate in opposite directions to achieve pivot steering. The same scientists are also working on developing a super-fast maglev train powered by high-temperature superconductors. As we see, the applications of magnetic technology are only limited by our imagination. In what other places do you think it can transform our lives? And could it result in completely new inventions?